In today's video, we are going to be checking out the Jackery Explorer 2000 Plus. This is the first line of power stations from Jackery that utilizes LFP batteries. Now, I have received so many direct emails and comments on my channel wanting me to test this model, so in this video, we're going to see how it actually performs. The Explorer 2000 Plus is loaded with features. On the front, you have this massive 3000 watt inverter, which will allow you to power some of the larger appliances in your home. If you have an RV or trailer, you can also connect up via the 30 amp RV port on the front. This does support internal fast wall charging. It'll charge from 0% up to 100% in around an hour and a half, and you also have the ability to adjust the AC charging speeds. Built into this is a 20 millisecond UPS mode or uninterrupted power supply, and we'll be testing that later in the video. Now, what about solar input? This supports up to 1400 watts via solar panels via 2 charging ports on the back. Each one supports 700 watts each. Now, you do have the ability to connect to this with the new Jackery Smart app, where you can connect via Bluetooth or Wi-Fi. And as mentioned before, this does have lithium iron phosphate batteries advertised for 2042 watt hours of capacity, and they are rated for 4000 charge cycles till 70% of the original capacity. Now, you do have the ability to connect expansion batteries up to this unit. There's a DC port on the back where they connect in, and each expansion battery adds an additional 2000 watt hours. So if you wanted longer runtime, you can connect up multiple batteries. Now, what about 240 volts output? If you purchase 2 of these units and connect them via a special hub, you can get split phase power at 240 volts up to 6000 watts output. So if you purchase expansion batteries and multiple units, you can have quite the backup system. Now, Jackery has been around for over 11 years, and they were one of the first companies to make a power station, so they have a lot of expertise there. Now, this product has a standard 3-year warranty, and if you register it, you can get a full 5 years. And if you are interested in purchasing this product, we are going to do the most extensive testing video you have seen, so I'd recommend sticking around to see how this actually performs. Now, the Explorer 2000 Plus has an MSRP of $2,199 on Jackery's website, but it's currently on sale for $330 off. This brings the price down to $1,869, or right around 91 cents per watt hour. Now, the most common use case for a power station of this size is to run your appliances during a power outage. You'll be using the AC inverter extensively during that use case, and I wanted to see how it performed. So let's jump into all the tests that I did on the AC inverter. The Jackery 2000 Plus inverter packs enough power to keep multiple appliances running during a power outage. First, I wanted to see how long the power station could run my full-size basement refrigerator. Keeping your food from spoiling during a power outage can save you hundreds of dollars. Starting at 100% state of charge, the fridge pulled a little under 150 watts while running, and checking in 23 hours later, the power station shut off as it hit 0% state of charge. That's a decent runtime, and remember, it can go even longer if you charge up with solar panels or connect their expansion batteries. Powering a microwave during an outage can be extremely beneficial if you need to cook food or boil water. The microwave here in my basement is rated for 1000 watts output, and when running the microwave off the 3000 watt inverter, it pulled around 1700 watts of power. Since this has such a large inverter, you could run multiple appliances at the same time without overloading it. Now, what if you were off-grid or the power was out and you wanted to power large tools? I wanted to see if the 2000 Plus could power my 10-inch compound sliding miter saw. This is the largest saw that I have, and it requires quite a bit of surge capacity to start up the motor. When making multiple cuts on a cedar 2x4, the inverter handled the surge load really well. The wattage jumped all the way up to 2500 watts when the saw kicked in. Handling power tools like this should not be an issue with this huge inverter. In the next series of tests, I wanted to verify the quality of the power that the inverter puts out. By pushing the inverter to the maximum output for 15 minutes, we can see if it holds the full rated wattage without overheating or experiencing any voltage drop. Once I enabled the inverter and connected my load, it was pulling right under the 3000 watt limit. After the test had been going for a few minutes, I checked the output with my oscilloscope, and it was a very clean sine wave at 60 Hertz, and using my voltmeter, I could also see it was sitting at a steady 118.4 volts output, so no voltage drop even under max load. Once the test had been going for about 10 minutes, the power station fans were at their highest speeds, and when testing the loudness of these fans, I was getting around 53 decibels at 3 feet away, and here's a demo of what the fans sounded like. I also wanted to see how well the power station fans were dissipating heat. Using my thermal camera to take pictures from multiple angles, you can see the max temperature I measured during this test was 112 degrees Fahrenheit, with other temperatures around 100 degrees or less. This shows the fans work really well to keep the power station cool. Within the next couple minutes, my stopwatch hit the 15-minute mark, and the Jackery passed the max load test. Now, how many watts will the inverter actually allow you to pull before it shuts down? I continued to raise the load on the power station until it hit 3,500 watts. It let me pull 3,550 watts for about a minute before it finally shut down from being overloaded. That is super impressive. The Jackery 2000 Plus also has the ability to act as an uninterrupted power supply. This means that when you have the power station plugged into a wall outlet, it bypasses the internal battery and puts power straight out to your devices. When it senses grid power going down, the power station automatically swaps over from wall power to using the batteries inside. This is advertised to happen within 20 milliseconds on the Jackery 2000. I tested the UPS functionality with my desktop workstation, an LED monitor, and my studio lights all running off the inverter. I simulated 6 different power outages by unplugging the power station from the wall while running the load. 6 out of 6 times the PC and monitor were still running after it was unplugged. With these impressive results, it appears the Jackery UPS mode is fast enough to support sensitive electronics as the power goes out. Some of my viewers power sensitive electronics like ham radio equipment or portable speakers on their power stations. And for that reason, I'd like to test for noise or interference that the power station may create. Using my dirty electricity meter, the EMI reading was very low at only 750 millivolts of noise. This is one of the lowest numbers I have ever seen on a power station, so good job, Jackery. To confirm this, I plugged in my guitar amp, and this is what it sounded like versus wall power. I also wanted to test what type of interference I would hear on a small handheld AM radio. With the AC inverter enabled, these were the results of the test.
No, I don't, and that's 100%. Stuck to is all right.
Because of this interference, I'd recommend keeping your radio equipment at least a couple feet away from the power station. The final test that I completed on the 2000 Plus were both for the AC capacity and AC idle results. The internal battery is rated for 2,042 watt hours of capacity. When draining down the power station at a 0.2C rate, I was able to pull 1,780 watt hours of capacity. This result of 1,780 watt hours is 87% of the advertised capacity. These results were right on par since my goal is to hit at least 85% of the rated capacity when discharging a power station. Now, how much power is used as the AC inverter is enabled and sitting idle? I started with the power station at 100% state of charge and left the inverter enabled for 13 hours with no load. When I came back, it was sitting at 85% state of charge, meaning the inverter had used around 15% of the battery after 13 hours, or about 1.15% per hour. Most power stations average around 1.5 to 2% per hour, so even with its larger inverter, this power station is super efficient while sitting idle. Wow guys, very impressive results while testing the AC inverter. We got the full 120 volts output. It was a pure sine wave. There was no noise on the AC inverter. We pulled the full 3,000 watts for 15 minutes and then pulled an additional 3,500 watts or above 3,500 watts for a minute before it actually shut down. For the capacity test, we got 87%, which is above par. Very impressive results. The fans weren't very loud. UPS functionality worked really well. So if you're looking to use this as a home backup, this is going to be an excellent option for all those tests. Now, there are people that want to use this in a van life build where, DC output is important, or maybe if they want to take like the ultimate power station camping, the size of this thing. So let's go ahead and test the DC output and the USB ports. The first thing I checked on the Jackery 2000 Plus was to see if the DC output voltage was regulated, meaning the voltage stays the same even while draining down the power station. When I plugged in my battery tester into the 12 volt socket, it was showing 13.1 volts. Looking at this specification sticker on the back, this model actually uses a 14S LFP battery with a nominal voltage of 44.8 volts. The 12 volt output is indeed regulated. The DC output is limited on this model with only one 12 volt cigarette connection that has a dust cover. The peak power I was able to pull with my battery load tester was around 155 watts. This is actually slightly higher wattage than other big brands I've recently tested. To get multiple devices connected, you could purchase a 12 volt splitter adapter like this. This would allow you to split the 155 watt load between two devices at the same time. How does the DC output enabled affect a handheld radio? Here's a demo of what happens.
We'll help you save money and /protect.
As long as you keep the radio equipment a couple feet away from the power station, you should be fine. I then moved on to testing all 4 USB ports. This power station supports 2 100-watt USB-C power delivery ports, and I was able to charge both my Energizer 320 and my EcoFlow River 2 Pro successfully at 100 watts each. I also tested the 2 USB-A ports by plugging in a USB fan and an LED light, and they both stayed powered on without an issue. With all 4 USB ports in use, I was able to pull over 200 watts total from the power station. In the next test, I wanted to get an idea of the maximum output the power station could handle with both the 12-volt outputs and the USB ports charging multiple devices. I connected up multiple loads to the power station at the same time to stress it out, and I was able to pull over 350 watts continuously from the DC output. Some power stations I have tested on the channel will shut off the DC output only after a few minutes. This makes it impossible to run a small fan, CPAP, or 12-volt fridge overnight. Luckily, Jackery has a setting within their smart app to keep the outputs from shutting down automatically. In order to test that setting out, I did plug in my Iceco VL35 Pro 12-volt fridge into the 12-volt cigarette port. I came back after 28 hours, and the DC output was still powered on, and the battery had only dropped down to 73%, meaning you get quite the runtime if you were camping with this power station and a 12-volt fridge. The final test I completed on the DC output were capacity and idle power usage tests. The 2000 Plus is advertised to have 2042 watt hours of capacity, and while draining the power station completely down via the 12-volt socket, I was able to pull a total of 1,821 watt hours over a 16-hour time period. These results were an impressive 89% of the advertised capacity. Most large power stations get below 85% on DC testing, so this was a nice surprise. In the next test, I like to see how much power the DC output uses while sitting idle if left on for a long period of time. I started the test at 100% state of charge on the power station, and checking in 13 hours later, it was at 96% state of charge, meaning the DC output is very efficient and only uses 0.3% per hour while sitting enabled with no load. Now, recapping the DC performance tests, well, I would have liked to see multiple DC outputs. It is kind of a bummer that it has one 12-volt cigarette plug, so you will have to buy a splitter to power 2 things at once. Now, for the actual power that we got from that, 155 watts. That's above average. That's good. That means this will power diesel heaters, 12-volt fridges, CPAPs, even 12-volt air compressors. You're not going to have a problem. So it is good to get the full 155 watts from that port. Now, the other impressive thing was the ability to get 89% of the advertised capacity on our discharge test. That means we got more usable capacity through the 12-volt socket than we did through the AC inverter. So pretty impressive there. In the next section of the video, I want to talk about the charging options for the Jackery 2000 Plus. Now, in the box, you get this nice carrying bag that holds these cables and adapters. Right here is your AC charging cable, meaning there are no external charging bricks. You just have to plug this into the wall. Right here is a DC charging cable, plugs into a female 12-volt socket. And you also have these 2 adapters. These are 7909 to 8020 adapters that allow you to use different Jackery solar panels or even your own solar panels. Now, on the back of the power station, behind this flap here, you have your charging inputs. So right here, you have your AC input. This is where you can charge from a wall outlet or a gas generator, and it supports 15 amps or 1800 watts. Down here, you have your DC input, where you have 2 80/20 barrel ports. Now, breaking down the specifications for each one of these DC ports, they allow a voltage range of 11 all the way up to 60 volts, and you do have a 12 amp input limit on the top end. Each port allows for 700 watts. You can get a peak input of 1400 watts using both ports at the same time. Now, when charging the Jackery 2000 Plus off a 12-volt battery, using their standard charging cable, you're going to get around 95 watts input. Now, keep in mind, this will take around 20 hours to fill the power station from 0 all the way up to 100%. Now, if you want to charge faster from a standalone 12-volt battery, you can purchase a 12 to 24-volt boost converter. So you can see on the screen, we're charging at 267 watts, so a lot faster charging here. Now, Jackery does advise not to use the 12-volt charging cable for this because it's charging at the higher amperage limit, which is going to make that cable very warm. So I would recommend using your own charging cable if you plan to charge from 24 volts. Now, because the Jackery power station allows for up to 60 volts input, we can charge with a 48-volt server rack battery. Now, this has a total voltage right now at 100% state of charge of 54 volts, so this should be fine to connect up. So let's go ahead and plug it in and see what we can get. Now, for this test, we're going to be using a 12-gauge wire with a fuse on the positive line. We're going from Anderson power pole to 7909, which plugs into the 80/20 adapter. Now I've gone ahead and connected up the battery. Now check out this, guys. We're getting 1200 watts over that one charging port. Now this is not good because I'm putting a lot of amperage through that 12 gauge wire and it's heating up. So technically it should limit to around 700 watts for each port, right? Well, I'm gonna go ahead and connect up a second port so we can split the amperage and keep these from getting too hot. So now I have 2 of these cables connected up, so we're gonna be splitting the amperage and these aren't gonna get nearly as hot. Now I've gone ahead and connected up both charging cables so we can split the amperage. Now we're getting 1075 watts input, so a little bit less power. Not sure why there's a little less power there, but it's still charging fairly quickly from that 48 volt battery. Now what happens if you dual charge the Jackery power station? I have the 48 volt battery connected up and I plugged the unit into the wall using the AC charger. Let's take a closer look at the screen. Now with both charging inputs connected, we're getting 1800 watts into the power station. And you can see these icons down here, the AC charging and solar charging. Remember, the 48 volt battery is being treated as solar panels. Now if we look at the screen of my 48 volt battery, you can see we're still pulling 20 amps from this battery while dual charging. So the power station does give priority to solar or DC input first, and then it tops off the rest with AC charging. In the next test, I want to see how fast the Jackery 2000 Plus will charge via AC input. With the Jackery connected to the wall, we're currently charging at 1500 watts. Now the owner's manual does state that this will charge at up to 15 amps, but we're seeing around 12.5 amps right now. Now within the Jackery Smart app, you do have the ability to adjust the charging settings. I selected quiet charging mode, which allows you to charge at a much slower speed. You can see here on the power station, we're charging at around 550 watts, which puts a lot less stress on the internal batteries. So anytime you're not in a rush, I do recommend using this slower charging speed. Remember, the less stress on the internal battery means you get more charge cycles and a longer lifespan of the internal battery down the road. As my final charging test, I wanted to test pass-through charging, or the ability to charge and discharge the power station at the same time. In this test, I had the DC output, USB ports, and AC inverter all enabled while charging the Jackery at the same time from AC power. Looking closer at the screen, you can see that the 2000 Plus was able to both charge and power the loads at the same time without an issue. Okay, so let's go ahead and do some real-world solar testing with the Jackery 2000 Plus. So I have 2 arrays that we'll be testing. Now, as for the conditions today, it is around 85 degrees, just a little bit of haze, but it is very clear. So I'm interested to see what we'll get on the power station. So the first array that we're going to connect up to the Jackery are these 380 New Power solar panels. Now these are special because they have a very low VOC. So with 3 of these in series, you actually get under 60 volts, which is compatible with the Jackery charge controller. Now I like how they include this adapter in the box. So I'm going Anderson power pole to 7909, and then included in the box are these 80/20 adapters that plug into the 7909 connection, so I can actually plug in my own solar panels to the power station. Now I've gone ahead and connected up the 3 New Power solar panels that are in series. We're getting around 509 watts input, so that's actually pretty decent from those 3 solar panels. Now unfortunately, New Power no longer makes these solar panels, but they are available on Amazon still. I'll include a link down in the video description. So if you have a power station that has a 60 volt cutoff, you may be interested in these solar panels. Now we also want to test these Renogy 200 watt flex panels on the power station. Now unfortunately, these have too high of a voltage to connect in a 3S or 4S configuration. So what I have to do is connect these 2 in series, and then I'm going to connect these 2 in series, and then I'll put that whole thing in parallel so we stay under 60 volts. So let's go ahead and connect this up and see what happens. Now with the Renogy solar panels connected up, we're getting around 714 watts charging input, so around 200 watts more using these solar panels versus the New Power solar panels. Now what's really cool is the Jackery power station has 2 different charging ports on the back, so you can connect in multiple solar panels. I'm curious what's going to happen if we connect both these arrays at the same time, so let's go ahead and connect them up and see if we can break the 1000 watt level. Now with both solar arrays connected up, we're getting around 971 watts input. Now this is interesting because wouldn't you get around 1200 watts if both of them were connected and it had 2 independent charge controllers? But what I'm thinking is going on is this has 1 charge controller, and if you have 2 separate arrays, it's going to average them out. So it's going to bring the voltage of one down and the voltage of one up. And when they meet in the middle, they don't get quite as much power. So we're only getting 974 watts versus the 1200 watts that we got from each array independently. Now there is a separate fan for the charge controller when you're maxing it out like this. So let me go ahead and give you a demo of what it sounds like and how loud it is. Now, Jackery does cover this in their owner's manual. They state anytime you dual charge with solar panels, you want to have matched solar panels on each side. And this is because those ports act like a parallel adapter. If you have mismatched solar panels, you could damage your solar panels or not get the best performance. For example, they say do not connect 2 solar panels versus 1, or 3 versus 1, or 3 versus 2. You want to make sure that you have the same solar panel array on each of those ports. So with that information, as long as you have 2 solar arrays that are identical, connected in parallel, you should be able to get pretty close to the 1400 watts charging, because we were able to get over 700 watts with this array here. Now, what happens to the power station under low light conditions when solar is connected? In the morning, I tested this when the solar panels did not have direct light on them. Now, the power station actually turned on, but you can see that it was not charging. I had to wait for the solar panels to get direct light onto them, and then I checked in and the power station was charging around 20 watts. Now, I did not hear any relay clicking noises, and I didn't see any errors on the screen, so it does appear that you can have solar connected to this 24/7 without any issues. So breaking down some of the charging tests that we did, this does have fast internal AC charging. Via the Smart app, you can adjust the charging speed to put less stress on the internal battery, so that's good. For dual charging, it did accept DC and AC input at the same time, and it did prioritize DC input, meaning it will charge with solar panels as the priority or DC input from batteries as the priority versus AC charging. Now, this does support pass-through charging as well, meaning you can charge it and discharge it at the same time, so no issues there. Now, what about the full 1400 watts via solar panels? Is it actually attainable? Now, if you look at the actual specs, 60 volts peak times 24 amps, that's 1440 watts. Most solar panels are going to get their peak power at a lower voltage, maybe around 48 to 50 volts. So you'll have to times that by 24, and that'll be your realistic number for the total power input via solar panels. It's a little bit tough with that 60 volt cutoff. Now, we did get 750 watts or so from that one Renogy panel. So maybe if you doubled that and had 2 of those on each side, you get pretty close to the 1400 watts. I don't have 2 of those arrays to test, so it's hard to see if we can hit the full 1400 watts. Now, the Jackery 2000 Plus does have Smart app connectivity. I've binded it up in the app, so let's go ahead and check it out. So at the top, you get your state of charge. You see it's sitting at 81%, and we also have a active temperature, so 71 degrees Fahrenheit. Down a little bit farther, you can see your input wattage and your output wattage. I am actually charging a device via USB-C, so you can see we have 104 watts going out. Down here, you can turn off the screen, so you can have the screen set to off. You can have it on for 2 minutes or on for 2 hours. You also have a bunch of other settings up here at the top. You can edit the device name. The charging settings allow you to set up quiet charging mode or slow charging. This sets it to be around 500 to 550 watts. And then if you have it set to fast charging mode, it does not put any limits on the charging. Now, what's cool about this is this works for solar and AC charging. Now, right here, you have battery settings. This allows you to limit the battery usage so it does not discharge it all the way. So you can save 30% of the battery life by setting it to this, giving you more life cycles down the road. Now, with LFP batteries, this isn't a huge deal, so I have it set to fully use the entire battery. Now, right here, you have your auto shut-off settings. So I have this set to never, but you can set it to turn off after 24 hours or 12 hours. And then for auto off here, this is like a hibernation for the entire machine. So if the machine is just sitting on, you can tell it when to turn off there. You can upgrade the firmware, which is nice. You can see it's already upgraded to the current version. You can see the device specifications and the entire user manual within the app. So lots of really cool things available in this Smart app. Now, when you purchase a product like this, it's important to know if the company will stand behind it, especially if you have issues down the road. Now, Jackery offers a 3-year warranty for this product, and if you register it on their website, you can get an additional 2 years for a full 5-year warranty. Now, what about customer support for Jackery? I always like to test this with the power stations that I review. Now, Jackery has a phone number that you can dial. I called it up during business hours, and I was able to speak with a representative with clear English after about 2 minutes of being on hold. Now, to see if they could understand what the product was, I asked them a few basic questions. One of those questions was, can I connect my own third-party solar panels to your power station? They put me on a brief hold, and after they came back, they gave me the full specifications for the power station and stated that I should make sure that I do not go over the 60 volt limit, because if I'm using my own third-party solar panel and I damage the power station, it would not be covered under warranty. And they did say that this would not be a problem with their own solar panels. I thought that was pretty useful information. They understood what the product was and they were able to give me that information. They also let me know if I had any other future questions, I could email hellojackery.com, and they strive for a 24-hour response time. Well, now that I finished testing the Explorer 2000 Plus, let's take these results and put this power station through my grading system. Now, I just upgraded to the 2.0 grading system where I raised the bar significantly so that it's much harder to get a 100% score. Power stations keep getting better and better, and I had to make it a better system. Now, this is what sets my channel apart from other reviewers on YouTube, is I can compare all the power stations I've ever tested on the channel against this one so you can see how it stacks up against the competition. Now, there are 10 points available. There are 20 very strict requirements that are required to get a full score, so let's see how it did. So here are the results for the Jackery Explorer 2000 Plus. If you look at the bottom right, you can see the final grade, it got an A, or 9.5 out of 10 points available. Now remember, each one of these requirements is worth a half point. So the second point here, which was the price per watt hour under 80 cents, because it was priced at 91 cents per watt hour, it did not get a point here, but it did really well at meeting all the other requirements. So how does this compare against other models that I've tested? Looking at my power station grading system, you can see the Jackery Explorer 2000 Plus at the top with a score of 9.5 points. And then right below that, you have the EcoFlow Delta 2 Max with 8 points, the Anker Solix F2000 with 8 points, and the Bluetti AC200 Max with 8 points. Now you can look through this grading system to see how they differ on the actual score. And if you check out the second tab, it breaks down all the actual results and numbers for every test that I did. Now this is the first Jackery power station that I've reviewed and tested on the channel, and overall I think the build quality, the performance, customer support, all that is really good for this power station. Some of the advantages, well, this has a 3,000 watt inverter versus some of the competition that has a 2,400 watt inverter or less. This also has the wheels and the handle that make it easier to move around. Some of the negatives, well, I kind of don't like that it only has one DC output. You can still get 155 watts from that, but you'd have to use a splitter to power two different things. Now you guys have to let me know, what do you think about the Explorer 2000 Plus? Throw a comment down below. Now I am wanting to do a future comparison video with these 2,000 watt hour devices. So if this video gets a lot of thumbs ups, then I'll know you guys want to do a future comparison video. Now, if you guys aren't subscribed to the channel, I invite you guys to subscribe. Go back and check out all my previous power station review videos because I have a ton of them. And of course, the power station grading sheet down in the video description, you can see how they all stack up against each other. Thanks for watching. Hopefully we'll see you guys in the next video.